Hey guys, it's Broihon again from guideattacking.com, and welcome to the second part of the manual mapping series. And if you didn't watch the first part, you should definitely check it out. So let's get right into loading the actual manual mapping file. I'm quickly going to copy the function prototype we declared in the first part. And let's start off by declaring a few variables we are going to use in this function. First of all, we're going to create a byte pointer. I'll call it psource data. And at the beginning, it's a null pointer. Also going to need a pointer to the nt header, which nt is the old nt header. Also a null pointer, and pointer to the optional header, pointer. A pointer to the file header, old file header, and last but not least, a pointer to the target base, which will be the target base will be the base address of the module in the target process. So this again looks like garbage. So find it. This. I just prefer to lay out the code properly because then you actually know what's going on. It just doesn't look ugly. Okay. Start off by checking if the file actually exists. Maybe this path is not valid. For that we are going to declare a new keyword, dv-check, and we are going to use a function called getFileAttributes. So if not getFileAttribute as a DLL file, don't even need the word, whatever. Then printf file doesn't exist and return false. Because if the file doesn't exist, we can't really inject it, do we? Then let's create an if stream, std if stream. I'll just call it file and pass the pointer to file name, and we are going to open this in binary mode. Binary and std iOS 8. So if file.fail means if opening the file failed for some reason, we don't know, let's actually printf opening file failed, and then we have an error code for that, but not by calling getLastError, but by using file .rdstate, which just returns a bunch of flags, and in case it fails, we can compare those flags to the documentation on MSDN and return false. Good. After that's done, we are going to check the file size. Maybe someone is passing an invalid file, which is not actually a DLL. So let's just make sure it's actually a file size. Also, we're going to need the file size when we read the file into memory. File.tell v. And if the file size is smaller than 1000 bytes, so actually it's 4096 bytes, but I'm using decimal, then the file size is invalid. If file size valid and false, and what I forgot to do is to actually close the file handle, because in this case file handle was opened successfully, and I guess you can do the same. Good. So the file size is valid. So now we can start reading the file into memory. So let's actually allocate some memory for file. For that, I'm going to use psource data and create a new byte array and pass file size. I'm actually going to static cast it, because otherwise we'll get some nasty warnings. Static cast into pointer size. So in case the file is too big, this might fail. We are going to check if source data was actually allocated successfully. If not psource data, printf memory allocation failed. Yeah, and close the file handle. Also, I'm just copy this because I'm lazy. That's done. We are going to do also we just use tellg, and this will set the file pointer to the end of the file. That's why we have to now go back to the beginning of the file. For that we are going to use file seek g. First parameter doesn't really matter, and std ios back for beginning. Now the file pointer is set back to the beginning. After that's done, we can read the whole file into memory. File.read, and this actually takes a char and not a byte, so we are going to read cast the psource into a char source data in this case. And we want to read the whole file, so let's use size we define, file size. And after that we can close the file. You could do some additional error checking for read and seekg, but if opening the file succeeded and the file size is valid and we got memory, there isn't really anything that goes wrong. Unless you delete the file between when this is code. This code is running, but I don't think that will happen. So now it's time to check whether the file is an actual DLL file. For that, let's reinterpret the psource data into an image DOS header. DOS header pointer actually. Psource data. And check the magic number. And this has to be equal to 0x5a4d. And this is the magic number used by almost all Windows executables. So yeah, I've opened the Wikipedia site of DOS MZ executable, and MZ stands for Mark Zybowski or Zykowski, whatever. So he's the guy who invented it, and that's why he used MZ to check whether a file is a valid PE file. So if this isn't equal to MZ, so number means MZ. If this is not equal, the file isn't valid. So let's printf invalid file and and also delete buffer we allocated previously with psource data. So after that's done, we're going to initialize the variables we declared here. So actually they're already initialized, but who cares? Pold nt header is equal to bitcast nt headers pointer psource data plus cast image DOS header source data plus elfa new. So what this does is, this is basically the base address of our module at the moment, and the elfa new member of the DOS header points to the new NT header. There's no really better way than doing some casting to get a pointer to the NT header. Now let's get the optional header and the file header. Old optional header and we'll just use the address of operator. And both of those headers are substructures of the NT header actually. So this and pold file header, file header. And of course, I'm going to lay out the code a little more. So we want to make this project work for both x64 and x86 modules. So let's add a quick check for the current platform we are on. If dev win64, else if vielmehr, else ever, doesn't matter. I mean, if you compile this in Titanium mode or something, it's your fault. And if. So if we find win64, if pold file header, quickly change this to 64-bit file header machine, and if that's not equal to image file machine AMD64, then it's not a valid 64-bit DLL file. Printf invalid 64 or invalid platform, whatever. We just have to know what went wrong afterwards. We allocate buffer, source data, and return false. Copy this and switch back to 6. So for 86 we have to use another flag, which is image file machine i386. The I stands for Intel, because Intel owns x68 and AMD owns 64 basically. So if it's an invalid, if this is not equal, it's not a valid x86 DLL file. So let me quickly check my notes here for a second. Yeah, perfect. And now we are going to allocate memory in the target process. For that we are going to use target base. And since we are going to use virtual alloc x, which returns a void pointer, we have to cast it into virtual alloc cast the process handle. Now we are going to use the image base member of the optional header, because every DLL, every portable executable, so any sys file, any exe, any screensaver even, has a preferred image base. So that's the address where the image prefers to be loaded to. And if it's actually possible to load the DLL at the image base, we don't have to relocate it, which makes our life a little bit easier. Yeah, pold optional headers. So the size we are going to use is defined in the optional header as size of image. Let's commit the memory and let's also make it, let's also reserve it. And we are just going to use page execute read write. Perfect. So if this failed, that can mean that can't allocate memory at the image base. So we are just going to initialize it, copy this, and instead of pathing the image base here, we are just going to path a null pointer. So, and if this failed again for some reason, then .ptarget base on, then there's no way to allocate memory in the target process. can either be because you're running out of RAM or because an anticheat is protecting it or whatever. So printf memory allocation failed. In this case I'm going to add a little x because we already used memory allocation failed for the internal memory allocation. Failed. And also pass the get last error code. This, and yeah, let's just call get last error. This. Deallocate the buffer, delete p source data, and return. Great, now we have the memory allocated in the target process. This, perfect. And we can start actually setting up the sections. So before we are going to map the sections into the target process and set up the structure we defined here, the manual mapping data structure. So let's copy this and create a new structure. I'll just call it data. And data.LoadLibrary A will just be a pointer to library A. Data.getProcAddress, set this to y LoadLibrary A. So, and we'll set this to getProcAddress. So this won't work because we defined getProcAddress a little bit different than the original ProcAddress. So let's cast it into fgetProcAddress, the function prototype we actually declared like this. So now let's start mapping the sections. First of all, we are going to get the section header, the section header, and for this we can use the image first section macro, which is defined in winnt.h, I believe, and pass the pointer to the nt header. So basically the first section is what comes right after the optional header, and this macro, let's quickly check the definition. As you can see, it takes the nt header, it adds the field offset of the optional header and then the size of the optional header, so it just points directly to the section after the optional header. And the section behind the optional header is actually the section header. You can hear if we hover over the auto, it's an image section header pointer. So let's loop through all the sections for u and I 0, I not equal to old file header, number of sections, plus I, and we can also plus the section header. Just go to the next section header. So if the section header has size of raw data, then we have to copy it. Otherwise, we don't have to. If not write process memory, hproc of course. Now we pass the target base, which we allocated here, plus p section header virtual address. So the virtual address is the offset from the target base to the actual section in memory. And the source data will be p source data plus p section header, p section header pointer to raw data. The size is also defined in the section header, p section header, size of raw data, and set this to a pointer. So if this failed, something went wrong. So again, let's print the error code and and sections. Again, get last error, of course. get error. This. And let's delete source data, and also deallocate the memory in the target process. Virtual 3x with hproc, target base, and memory. We don't have to decommit it. It will be enough, and return false. So if that's done, so let me quickly explain this again. The number of sections is the number of sections we have to copy, of course, but we only care about the sections which actually have raw data. There are sections with data which isn't initialized at start, which then will be initialized at runtime, and we don't have to care about it at all. So we are writing to ptargetBase plus the relative offset to the section, and the source data is just the pointer to the... So the source data is what we loaded from the file using read, and the size of the section is size of raw data. And if that failed, one section couldn't be copied into the target process, and of course there's a section missing, our DLL can't run properly. Good. So for now, that'll be it for this part of the tutorial. In the next part, in part 3, we are going to write the shellcode, which then loads the actual DLL. Bye.